Hello students, welcome to lesson 2.1 talking about speed, position, and direction. Today your learning goal is let's use signed numbers to represent movement, and your learning targets are I can multiply positive with a negative number and I can use rational numbers to represent direction. Here is the standard we are talking about. And here's how you're going to get your journal page set up. Don't forget to write down your standard learning targets and the date and get those question strips glued on in. All right, let's dig in. We're going to start with a little warm-up of our brains talking about distance equals rate times time, which is a formula that can be really helpful in both math and science. And what I went ahead and did is I used this D equals RT. And let's remember here that when we have two variables right next to each other, that means multiplication. And I broke it up into three different formulas depending on what it is we're looking for. So if we're looking for distance, we can use our rate multiplied by our time. If we're looking for our rate, we can use our distance divided by our time. And if we're looking for our time, we can use our distance divided by our rate. And I'm going to be using this amazing Olympics skateboard team medal winner, Alexis Labone, to talk about these problems. So here in this first problem, we have Alexis, and she is skating at a constant rate of 8 miles per hour. So I'm going to go ahead and highlight that because we know her rate. And she's going for 3 hours. So I'm going to highlight that so we know her time. And what we are looking for is what distance she traveled. So go ahead and pause this and see if you can solve it. So what I went ahead and did was I set up distance equals our rate of 8 times our time of 3. And so I got that our distance equals 24. So she traveled 24 miles. Don't forget those units. All right, second up, we have Alexis, and she is skating at a constant rate, and she travels 29 miles in 4 hours. So what we want to know what her speed is. And speed, again, here is our rate. So what we know is we know the distance, right? She went 29 miles, and we know the time in 4 hours. So go ahead and pause it and see how you would set this up and solve it. All right, here's what I did. I said, well, if our rate equals distance divided by time, then our rate for Alexis equals 29 miles divided by 4 hours, which means that our rate is 7.25 miles per hour. Again, don't forget those units. And then last up, now we have Alexis, and she is feeling sleepy, so she gets into a car. The car moves at a constant rate of 50 miles per hour. So again, I'm going to go ahead and highlight that because there's our rate, 50 miles per hour. How long does it take the car to go 200 miles? So there's our distance, 200 miles, and we are looking for that time. Go ahead and pause and get this set up. Here's what I set up. If time is our distance divided by our rate, then time is going to be 200 divided by 5. So this car went 200 miles in exactly 4 hours. All right, let's move forward. So now we're going to talk about multiplication on a number line and using this concept of moving left and moving right. So let's remember that when we were talking about addition, 0 often meant our boundary point between positive and negative values. So for example, let's just talk about this elevation. Remember that 0 meant sea level, and all of our positive numbers were above sea level. All of our negative numbers were below sea level. You can also think of what that meant for temperature, where 0 was freezing and all of our negative numbers were below freezing, positive numbers warmer than freezing, and money, where 0 meant we had no money, positive numbers meant we had money, and negative numbers meant we had debt. So how can we make sense of 0 then when we are talking about multiplication? And something I want you all to have highlighted in your journals is that when we're talking about multiplication, 0 can be seen as a reference point for position. So if I'm at 0, and that's my position, then all of my positive numbers would be positions on one side of the reference point. More specifically, all my positive numbers are to the right. and all of my negative numbers, positions on the other side, or more specifically, all positions to the left of 0. How would this look on a problem? So you're going to see these in your practice problems where we are given a starting position of 0, we're given our direction, right or left, speed, time, and then being asked to find our ending position and write an expression. This first example you will see on your practice problems where we are given the starting position of 0 and we are moving right, which means we are moving to the right, so in our positive direction, in groups of 5 and each group containing 3 seconds. And so we could see this as, well, moving to the right, there's 1 group, there's 2 groups, there's 3 groups, there's 4 groups, and 5 groups. We're landing here at 15. So we would say that 0 plus 5 times 3 is a positive 15. Let's check out what would happen if we are now moving left in group. So our speed is 3 and our time is 2.5. So we're going to be moving 3 groups of 2.5. So we're going to start at 0. And since we're moving to the left, in this case, I'm actually going to have a negative sign there, or minus 3 times 2.5. So let's check that out. Let me erase this arrow and go ahead and plot this. So here is 1 group of 2.5, and then there is 2 groups of 2.5, and then there is 3 groups of 2.5. So landing right here at negative 7.5. So I'd say my ending position is negative 7.5. So just remembering that moving to the left means you are moving in a negative direction. Moving to the right means you are moving in a positive direction. So one way we can talk about direction on a number line is using this term velocity. So please make sure you have this vocab written down. Velocity is speed in a given direction. Some examples right here, we have a car and the speed is simply how fast the car is traveling. So this car is traveling at a speed of 20 meters per second, whereas velocity is how far this or how fast this car is traveling in a given direction. So this car is traveling at a velocity of 20 meters per second heading east. Again, speed here would mean, well, this car is 25 meters per second, whereas the velocity would be 25 meters per second heading north. How can this look on a number line and with story problems? Well, here we have my most beautiful cat, Bella. Hi, Bella. And Bella is doing her favorite thing. She is sitting at her window. So in this case, our reference point of 0 is Bella's position. And she sees a crow pass by her flying west at 5 meters per minute. We're being asked to write an equation describing the crow's location 10 minutes after passing Bella. Go ahead and pause and see how you might make sense of this. So here I have set up a little formula where velocity multiplied by time will give you your ending position. So in this case, our velocity is the speed of the crow. So that crow is going 5 meters per minute west. Since west is all of our negative numbers, that means that this is going to be a negative 5 in the equation. So my velocity is going to be negative 5. My time is positive 10. My time is positive 10 because of 10 minutes. So time is going to be 10. Now, if we are moving negative velocity in positive time, that's going to look like negative 5 groups of 10. So we're going to say, well, there's 1, 2, 3, 4, 5 groups of 10. So this crow's landing position is negative 50. And we would write this, if Bella's reference position is 0, then this crow would be 50 meters west of Bella. All right, let's check out some other examples. So here's a you try it. Miss Sayler is at her classroom door, so Miss Sayler is our reference point for 0. Espen runs past her, heading east at 3 feet per second. Write an equation describing Espen's position in 5 seconds. And don't forget that running in the halls is naughty. Go ahead and pause and see if you can work this out. So here's what I worked out. If we're using the equation, velocity multiplied by time is our end position. My velocity here is 3 feet per second east, which means that east are all of my positive numbers, so my velocity is a positive 3. My time is 5 seconds, and that's a positive number also. So if time is positive, we know that a positive multiplied by a positive is going to be a positive. It's 15. But let's also look at what that would look like on this number line. So here's Espen running 3 groups of 5s. There's 1 group, 2 group, and 3 groups east. So we would say Espen was 15 feet east of Miss Sayler. All right, let's try one more. So here we have Miss B in her car. So Miss B is our reference point at 0, and she sees Kojo zoom past her on his bike at a velocity of 20 miles per hour heading west. Write an equation describing Kojo's position in 2.5 hours. If you see Kojo, tell him to be careful. That's very, very fast. Go ahead and pause and see if you can get this figured out. Here's what I wrote down. So my velocity, or Kojo's velocity, I should say, is 20 miles per hour west. Since west are all of my negatives, that means that my velocity is negative 20. So I'm going to write negative 20 in my formula. My time is positive 2.5. This is time moving forward, which means my ending position, negative 20, times positive 2.5, a negative times a positive will always be a negative. We're going to land at negative 50. What this would look like on the number line is negative 20 groups of 2.5. So I'm just going to go groups of 10 at a time. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups to land me at negative 25. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups to land me at negative 50. So there's negative 20 groups of 2.5. All right, your next step. Oh, no, let's write this out. So this would mean that Kojo is 50. Let's see, we did miles west of Miss B. All right, your next step is to go ahead and get those journal problems and do your practicing. Thank you so much.